So now we're going to move on from the quadrantal angles to the special angles. So this is our pi by 6, pi by 4, and pi by 3. So the first thing we want to look at is, what does pi by 6 look like in every quadrant? I know we've already done this, but it's never bad to do it again. So pi by 6 is our smallest angle. It's our 30-degree angle. And so pi by 6 would be here in the first quadrant. Now, you can count, pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, and 5 pi by 6, and that'll work. And then this would be 6 pi by 6. And that'll work to figure out kind of where things are, because just like the pi by 2s, like the quadrantal angles, we're going to have to figure them out as coterminal angles as well. But what I like to do is when it's a pi by 6 reference angle, then you're making that angle of pi by 6 with the x-axis in every quadrant. So instead of having to count all the way around, I'm just going to put all my pi by 6s in there. What I would do instead is think about, if pi by 6 is my reference angle, what would that look like in the second quadrant, in the third quadrant, in the fourth quadrant? So if you have a reference angle of pi by 6 in the second quadrant, you could see here the angle's 5 pi by 6, because it's 1 pi by 6 less than that full pi, which with a denominator of 6 would be 6 pi by 6. So 6 pi by 6 minus pi by 6 would give me 5 pi by 6. And then in quadrant 3, so this is quadrant 2, in quadrant 3, you would be doing that pi, which is 6 pi by 6, plus the pi by 6. So in quadrant 3, the angle would be 7 pi by 6. And then in quadrant 4, this is 2 pi, which could also be 12 pi by 6. Then you're going to be in here, and you're going to be 12 pi by 6 minus that pi by 6, which would make this angle 11 pi by 6. So yeah, there's a couple ways of getting there, like I was saying. So if you like this whole pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6, 6 pi by 6, 7 pi by 6, you can keep doing that, right? This would be 9 pi by 6. This would be 10 pi by 6. Then you get that 11 pi by 6 and 12 pi by 6. Or you could think of, if there's a reference angle of pi by 6, in quadrant 2 and 3, you're pi by 6 less and pi by 6 more than 6 pi by 6. And in quadrant 4, you're 1 pi by 6 less than 12 pi by 6. If we do the same thing with pi by 4, this is my reference angle of pi by 4. If I was to draw that in the second quadrant, you could think of pi minus pi by 4. So what would this angle be? Well, pi with a denominator of 4 would be 4 pi by 4. So 4 pi by 4, actually I could just squeeze that in here. 4 pi by 4 minus pi by 4 would leave me with this angle being 3 pi by 4. In quadrant 3, it would be this angle here, right? And so then you'd be going 4 pi by 4 plus pi by 4, which would give you 5 pi by 4. And then in quadrant 4, you'd be going 2 pi, which is equivalent to 8 pi by 4. So you could do 8 pi by 4 minus pi by 4, and this could be 7 pi by 4. Or kind of like the pi by 6, you could do 1 pi by 6, 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4, 6 pi by 4, 7 pi by 4, and 8 pi by 4. So there's a couple ways of kind of figuring out where these angles are going to be and what are the values in each of the quadrants. Lastly, pi by 3. So pi by 3 is our 60-degree angle. It's our biggest one. So it's the one going to be made in the quadrants with the largest reference angle. And so if this is pi by 6 in here, okay, then my reference angle is, pi by 3. Then here, if this is pi, we're going to call this 3 pi by 3. So in quadrant 2, you'd be 3 pi by 3 minus pi by 3, which would make this angle 2 pi by 3. In quadrant 3, you'd be 3 pi by 3 plus pi by 3, which would give you 4 pi by 3. And then in quadrant 4, you'd be 6 pi by 3 is 2 pi. So you could do 6 pi by 3 minus pi by 3, which would give you 5 pi by 3. Or like you did the other one, you could do 1 pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3, 5 pi by 3, and 6 pi by 3. And for this one, it kind of works to count that way. And it's interesting, it's kind of how your brain will grab onto it. Personally, I love making the angles with the x-axis. I find, especially for some stuff that we're going to do later, if I could picture pi as 3 pi by 3 and go less and more than 3 pi by 3, I find it quite easy to figure out where things go. But some people are better at proportionality, and they're like, no, I can see the thirds. Like, you're a third of the way to the pi, you're 2/3 of the way to the pi, you're at pi, right? So the moral of that story is do what makes sense. And if nothing makes sense, come and talk to me. So the first thing we're going to practice before we go into evaluating the function values is we're going to find reference angles. And then we're going to figure out what quadrant each of the following are going to be in. Now, the nice thing is that in radians, there's no question what the reference angle is. If the denominator is a 4, the reference angle is pi by 4. If the denominator is a 3, the reference angle is pi by 3. If the denominator is a 6, the reference angle is pi by 6. And then lastly, the reference angle for this one would be pi by 4. So the denominator in radians tells you exactly what the reference angle is going to be. Now to figure out which quadrant things are going to be in, we're going to draw it. And then if I'm dealing with a denominator of 4, I go straight to pi being 4 pi by 4 and 2 pi being 8 pi by 4. Then I figure out where would 7 pi by 4 fit. Well, 7 pi by 4 is 1 pi by 4 less than 8 pi by 4. So I know that I'm in quadrant 4. When I'm looking at this guy, again, I know my reference angle is going to be pi by 3, which is going to make this guy a 3 pi by 3, and this guy a 6 pi by 3, right? So pi and 2 pi. And then 2 pi by 3 is less than 3 pi by 3 by pi by 3. So I know that I'm in quadrant 2. Pause the video. So, well, these ones get a little bit harder, but see if you can do them. You can pause the video, give these two a try. Okay. Well, actually, this one's not bad. So for this one, 11 pi by 6. So again, as soon as I'm in a denominator of 6, I'm going to call pi 6 pi by 6, and I call 2 pi 12 pi by 6. And then I'm going to look, are you more or less than pi by 6 or 6 pi by 6, or are you more than less than 12 pi by 6? Well, I'm here. Right? 11 pi by 6 would be 1 pi by 6 less than 12 pi by 6, so this is going to be quadrant 4. And then they could do something tricky like this at you, like the negative 11 pi by 4. How are you going to figure out where that is? Well, I know my reference angle is pi by 4, so I have two choices. I could count by pi's of 4s, or I would start with labeling these. So whether you read it clockwise or counterclockwise, it's 4 pi by 4. It's just negative 4 pi by 4. This would be negative 8 pi by 4. And then 11 by 4 is not near any of those. So if I wanted to, I could find a coterminal angle to 11 pi by 4. So if I wanted to go coterminal, I could take the 11 pi by 4. Well, I guess I should put it as negative 11 pi by 4, and I could add 2 pi. So I could add 8 pi by 4, which would give me a negative 3 pi by 4, which would now tell me that I'm 1 pi by 4 less than 4 pi by 4. So this is going to be quadrant 3. If that makes no sense to you, count the quarters, right? So negative 11 quarters. So this is a quarter. So 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5, 6, 7, 8, 9, 10, 11 pi by 4. So there's a couple ways of figuring out what quadrant you're in, but the reference angle part is quite straightforward. So that now we can tie that all together. So I just wanted to practice that little mini skill first, because the next thing we're going to do is find function values using coordinates of points on a unit circle, giving exact answers in radians. So if I asked you to find the value of the tan of pi by 3, we already did this. Okay, we did this exact question earlier, and all we're going to do is make these ones harder. But steps. Step 1, I got to figure out what my reference angle is. Well, it's pi by 3. Then I have to figure out what quadrant I'm in. Well, I'm going to be in quadrant 1 with a reference angle of pi by 3. Then you have to remember your special triangles. So this is my 1, 2, root 3 triangle. So across from pi by 3 is my root 3. This is my 90, so that's my 2. And then this is my 30, or my pi by 6. and that would be my 1. So don't forget your special triangles. You know, some people will switch to degrees because we've been practicing so much in degrees, but I can't emphasize enough, try to do radians. So 2 ways of figuring out where things go. 1, pi by 6 is the smallest angle, so it gets the smallest side. 90 degrees always gets the 2. But what I like is that your pi by 3 gets the root 3. That's how I always kind of remember it. It doesn't work if you go to degrees though, because 30 degrees gets the 1. So just be careful. I know it's so, I almost wish our textbook never did anything in degrees, but I find when you're first learning things, it is nice in degrees because degrees make sense to us. So then you're just translating all those skills to radians. So now what we'd figure out is the tan of pi by 3 is opposite over adjacent, or y over x, which would be root 3 over 1, which would just be root 3. Then we've got 3 pi by 4. So this is where it gets kind of new. So 3 pi by 4, we're trying to figure out my reference angle. It's going to be pi by 4. I'm going to figure out what quadrant I'm in. So in a reference angle of pi by 4, pi would be 4 pi by 4. So 3 pi by 4 is 1 pi by 4 less than 4 pi by 4. So it's going to be my 1 root 2. Now, as soon as you leave quadrant 1, be careful with your signs. This x is in a negative direction, so it's going to be negative 1. And then cos of 3 pi by 4 is going to be adjacent over hypotenuse, or x over r, so negative 1 over root 2. And then you're going to rationalize your denominator. And you get negative root 2 over 2. All right, next one. Cotan of negative 5 pi by 6. Again, reference angle, pi by 6. Which quadrant? Well, I'm reading in a clockwise direction. Pi would be 6 pi by 6, or negative 6 pi by 6. So this is telling me that I am 1 pi by 6, and no, this is not proportional, away from 6 pi by 6, right? So I'm going to be in quadrant 3. This is pi by 6, so that's my smallest angle. So it's my 1, 2, root 3. Watch your signs, so negative, negative. And now cotan is going to be x over y, or adjacent over opposite, whichever one works better in your head. So it's going to be negative root 3 over negative 1, which would give you positive root 3. All right, lastly, sine of 4 pi by 3. I'm reading counterclockwise again. So this one, my reference angle is going to be pi by 3. So I'm going to make my pi into a 3 pi by 3. And then 4 pi by 3 is more. So it's going to be 1 pi by 3 more than 3 pi by 3. So it's my pi by 3, pi by 6, and 90 degree triangle. So this is going to be my 1, my 2, and my root 3. Watch your negatives. And then sine is y over r, or opposite over hypotenuse. So it's going to be negative root 3 over 2. Whew. Now, these are exact values. If you wanted to check these with your calculator, make sure your calculator is in radians. So we could go, I have to remember how to put my calculator in radians. There we go. I hit setup, 0, 1. Okay, so I could type in sine bracket 4 times pi divided by 3 unbracket, and I get this decimal, so I get negative 0.8660, and then I could plug in negative root 3 divided by 2, and I get that same thing. So it's a good way to check if you've done it correctly. When you're getting marks on your test, I will be giving marks for the picture. Right? I want to see that you knew the reference angle was pi by 3, you knew how to draw your special triangle, and from there you knew how to find the value of sine. All right, give that a go.